So, hello, welcome to our session 3. Today we are going to discuss transportation engineering, and the topic in the GATE previous year question we are going to cover is going to be stopping side distance and curve setback distance, and we are then going to discuss some more, uh, you know, uh, highway design questions. So let's start. So the first question is from GATE 2008, question number 84. So those years GATE used to give 85 questions, and it was only one set. Okay, so the question reads like a horizontal circular curve with a center line radius of 200 meters is provided on the lane on a two-way state highway section. The width of the two-lane road is 7 meters. The design speed of the section is 80 kilometers per hour. The brake reaction time is 2.4 seconds, and the coefficient of friction in longitudinal and lateral direction are 0.355 and 0.15 respectively. So what will be the safe stopping side distance on this section? So this is a two-part question. That's why there are a lot of details. The second part of the question we are going to solve just after this. So first part is it is asking us to calculate the safe stopping side distance. So what is stopping side distance? So when we are going on the road, or we are on a car, we are going on the road with some velocity, we see some obstacle, some other car has met some accident, or some person is walking. So we want to stop our car before we hit them. That's when so the distance, the safe distance before which we should see this person, so that when we apply brake, the reaction time before we apply brake, that distance, and after we apply brake, the distance the vehicle covers while slowing down to come zero. So the sum of these two distance is the stopping side distance. So what it is written like? It is written as SSD is equal to V, our initial speed, into our reaction time. So this is the distance we cover when we decide that we want to stop or not. Then V square by 2G F plus minus N. So this is the braking distance. So the distance it takes for us to stop after we have applied the brakes. Also in this is F is the friction coefficient. So they have given us two friction coefficients. They have given us longitudinal friction coefficient and lateral friction coefficient. So which one do you guys think we should use here? Should we use longitudinal or lateral? So for those who joined late, we are going to calculate the stopping side distance, and I am asking that the friction coefficient that we have in the stopping side distance, that is this F, is it longitudinal or lateral? Longitudinal, correct. So does everybody else understand? Okay, so let me just tell briefly. This is a road. This is the direction of movement. The friction coefficient in this direction between the tire and the road is called longitudinal. And if you remember, when we talk about horizontal curves, we say that we have to have some friction so that the vehicle, if it is taking a turn here, it doesn't skid over that. So we remember, if you remember, the road will be embanked, that we calculate. We'll see this type of question maybe in the after these two questions. So this is some, it gives some elevation to the outer edge of the road so that fast vehicles can go, here. In that we have E, and then we have a friction also. That in this case, which is perpendicular to the motion of the vehicle, is the lateral direction friction coefficient. Okay. So after we know all these things, it is just a substitution kind of problem. So let's put the formulas and get the value. So I usually don't like to remember a lot of formulas other than some basic formulas. So that's why I will not be writing the formulas separately for velocity in kilometer per hour and meter per second. I like to convert this into this by multiplying it with 5 by 18. And usually in GATE, they will give either 100 or 80 or something like that. So if you solve a lot of questions, you will know that 100 kilometer per hour, 80 kilometer per hour is nothing but 27.77 and 22.22 meter per second. So, if you solve a lot of questions, you will get a hang of these values. You don't even have to multiply and convert. Okay, so let's get to the question. So velocity is 22.22 meter per second into our reaction time 2.4 plus 22.22 square by 2 into 9.81 into the friction coefficient longitudinal. So what is the value here? Who can calculate and tell me what is the value of stopping side distance that you get and what is the correct answer according to you? Okay, so okay, then I will do it. So 20.22 into 2.4, we get 53.33 plus 22.22 square divided by 2 divided by 9.81 divided by 0.355, we get 70.88. So when you add these two, you get 124.2 meters, and the closest to that is 125 meters. So that is the answer. Okay. Is there any doubt in this question? So yeah, first you guys can ask, then I will ask maybe a possible next question. We have another question, next question for this, but a possible next question that may be asked in some exams. I will ask that. Okay, so if you guys don't have any questions, so my question to you is, now let's say the same curve was on a downhill. This is a mountain. This curve was like this on that mountain. Then what do you think the stopping side distance will it be more than what we previously calculated? So that is option A, or will it be less than what we previously calculated? What do you guys think? It will be less. M Muir is saying it will be less. Anyone else?
Sir, more the stopping side distance in pressure.
So Rishikesh Kumar is saying it is going to be more. So 1-1 we have what? Anyone else want to join in? Okay, so no one feels like joining. So the answer is Rishikesh is correct in this case. It is going to be more. Why? Why? Because when you are on a downhill and you apply brake, previously the brake had to stop you only for your momentum, whatever initial velocity you had. Now the whatever braking mechanism you have in your car, it is going to have to stop, compensate for the weight component which is acting in the downward direction, right? So it is going to take more distance for your car to stop after applying brakes. So your braking distance, that is v square by 2g f plus minus n, is going to increase, and that's why we have this plus minus. So when you have a downgrade, you subtract that particular gradient from this f value and get the increased. So denominator decreases, the braking distance increases. Is that clear? Okay. Then we'll go to the next question. So it's the same question, 2008-85. Horizontal same. So we have again 200-meter roads, two-way, two-lane, 7-meter wide, 80 km/h, 2.4 reaction time. These are all things. So we for this part we don't need. So we only need this, 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 and the answer from the first question. So one thing that I have noticed is if you get these type of questions, what I would suggest you to do is you use the answer from the first part. Let's say we have calculated SSD. Even though we calculated the SSD as 124.2, don't use that exact value when you are doing the second part, because it will give you different answer if you do that. So for this case, when we are asked to calculate the setback distance from the center line of the inner lane. So we'll see we have to use SSD here. We should use 125 meters. Okay. Okay, okay. Hmm. Yeah, so I thought someone messaged. So what is this setback distance? Why do we want to calculate it? What do you guys think? What is this setback distance? We can go on, apply formula, get the things done, but what do you think physically? Why do we even need setback distance? So before, let me actually just give you a hint. When we are on a curve, let's for simplicity, just let me draw a single lane. So single lane width, if anyone asks you, it is 3.75, and for any n lane, you know, road, it is n into 3.5. But for single, it is 3.7. So you can remember this also. Okay, so we have a single lane road, and this is the center line. The radius is going to be this from the center of the curve to the center of the road. And this setback distance is actually from this main highest curvature point to this. Let's say this is your stopping side distance. This is your setback distance. So why do you think we need this? And what usually is done is no kind of construction is allowed in this area. That's why this is a setback distance. So you should set back and start only after this much. Okay, so I'm not getting any volunteers for answer. So let me tell the answer then.
Can I speak?
Yeah, sure.
Yeah, actually, we have before providing this distance, we need to have certain required side distance. In order to provide that, in order to make that distance available side distance more than the required side distance, we are providing the setback in order to avoid that obstruction, which makes the side distance less.
Very good. Correct answer. Now, okay, so now let me explain for those who didn't understand. See, stopping side distance is the distance you should be able to see your obstacle before. Now, this is the safe distance that if you see your obstacle before this much distance and you apply brake, you will be able to stop. Now, if there is a curve, you can only see this much. If you are driving in a straight line and looking forward, you can only see till here, right? You can, if there is a construction on this side of the road, you cannot see past this point. Let's say, yeah, this is your vehicle, you cannot see past this point. But if you are not able to see, then you won't be able to avoid any kind of collision from the vehicle that is coming from here to here, because this is the side distance we have calculated. This is the stopping side distance. This much distance you need to stop, but because of the obstacle, because of the construction, how much distance you are left with? You are left with only this much distance. So using the stopping side distance, we calculate that how much we should push back the construction so that you are able to see, and based on your vision or based on your available vision, we get the full stopping side distance. Okay. Okay, let's try to solve the question. So we are given a 2-lane road. So let me draw a nice figure here. We have 2-lane road. So this is division of the lanes, and this is the division for two-way traffic. And we are given that the radius is 200 meter. And since we are not given the length of the curve, so if you remember, there are two type of conditions when length of the curve is greater than SSD, the stopping side distance, and the length of the curve is less than SSD. So since we are not given the length of the curve, we are going to use the SSD to calculate the setback distance. So this is the SSD we calculated from the previous part of the question, that is 125 meters. Okay, we are going to say that, okay, this is the length of the curve now. So this angle will be, and the angle actually what we calculate, we do this calculation. So if you look at it carefully, we want to do the we are asked, no, we are asked from the center line of the inner lane, right? So we have to calculate the angle using this particular arch. So this is the inner lane. Let me highlight it. This is inner lane. So we are going to calculate this distance, this arch angle, using this and this radius, which is a part of the radius. The whole radius starting from here, we have to use this part of the radius. So let us write what will be alpha in this case. So what we are going to assume is, when we are coming down here, this 125 doesn't change, because this guy also needs 125. No, the person going in the inner lane, this guy also needs the 125. So this 125 doesn't change, but the radius has dropped. So how much it has dropped, that we can calculate easily, because we have been given the full width of the road is 7 meters, and this is divided into 4 equal parts. So this is 1, 2, 3, 4. So this distance that we often call it as d in our formulas is going to be 7 by 4. So the alpha angle in radian, if we calculate, it will be 125 divided by 200 minus 1, sorry, 7 by 4. Yeah, 7 by 4. So what is this angle? Tell me in degrees. What is the angle in degrees? So what the value you will get, it will be radian, and then you multiply this by 180 into pi, 180 divided by pi, and you get the answer in degrees. Okay. So we don't seem to have any volunteers. Is anyone calculating? Okay, cool. I will give the answer. So this division will give you 6305, and when you convert it into degrees, let me do it. We will get 36.125 degree. Okay, yes, and Now let's calculate the setback distance. So 36.12. Okay, very good. Sumit Ranjan gave the answer. We have to calculate setback distance from the what was asked of us. We have to calculate the setback distance from the center line of the inner lane. So this is the distance we want to calculate, right? What is distance? What is this distance? This is nothing but this radius, which is the reduced radius, that is r minus d minus this component. And if you look at it carefully and we assume symmetry, this is alpha by 2 and this is r minus d. This length is going to be r minus d cos alpha by 2. So this distance, that is the whole reduced radius minus this particular part, is going to be r minus d minus r minus d cos alpha by 2. This is our setback distance, and often we call it as m. So let's calculate it. Let's get the value. So I am also calculating. Meanwhile, if you calculate before me, feel free to tell the answer. So I have calculated and the answer comes out to be 9.769 equal to 9.77 meters. Maybe this can be a little bit confusing. We just not call this anything, call this setback distance meters. So if you look at the answer here, we have 9.77 meters. And let me calculate this answer if we were to use our SSD that we got from the first, that we actually got 124.2, right? What answer we get if we use that SSD? Okay, so the alpha will change in that case. Alpha will be 124.2, just to highlight that you should not do that, because when I actually used it, I got another answer, and that unfortunately ended up being one of the answers in this option, and it can cost you your marks. So we have 0.6265 in radians, and if you convert it into your degrees, it is 35.89. See, it is not, the difference is not much, but you will see what answer we get. Setback distance. Okay, so if 200 minus 7 by 4 into 1 minus cos of our alpha by 2, that is 35.89 divided by 2. You see, we are going to get 9.64 meters. And when you get that, you are more inclined to give this answer rather than this answer, which can cost you some precious marks. Okay, so something just to keep in mind.
Excuse me, sir.
Yeah.
Yeah. Can you repeat this? Actually, unfortunately, I missed some of the minutes in the initial stage of the lecture. If you can please recall this, what we need to take and what we not need to take afterwards. Actually, I didn't get it properly.
This last part you're saying?
Yeah. Actually, this one.
Oh, okay. So this is nothing but, so I said that when we calculated our, so this question is a two-part question.
Right.
Yeah. So I'm muting
Right.
you, Mure, because
Okay.
there
Okay.
is a static
Okay.
that is coming. So I'm going to explain it. Yeah. So this is a two-part question. We are given all the details and for the curve. So first they asked us, what is the safe stopping sight distance? And when we calculated it, we got the answer to be 124.2, which is little bit different than 125, but then because this was the closest, we selected 125. And then I suggested that now that you got this answer of stopping side distance 125, you have selected this now. For the next question, when you have to use actually the stopping side distance to calculate the answer of second question, you use the option that you have selected in the
Yeah,
first part.
I got it, sir. I got it, sir.
Okay, okay,
Oh, it depends on the options that we have chosen initially in the first part, and accordingly we will do the calculation, right?
correct, correct.
Okay, okay. Thank you, thank you.
Okay, okay. So now let's go to the next. So now we'll go to some other questions that I have chosen for practice. Hmm. Okay. Oh my God. I solved them myself and I forgot to erase the answers. Okay, so I will ask you guys to be ethical and not remember the answer that we just saw. Summit curve is formed at the intersection of 3% up gradient and 5% down gradient to provide a stopping distance of 128 meters. The length of the summit curve needs to be how much? Okay, so what is a summit curve? When we go on the road, we get some uphill road section and downhill road section. So this uphill road section is the summit curve, and this downhill road section is the valley curve. They have their different formulas for design. Now here we are saying that the summit curve is formed by a road that is 3% in gradient going upwards and 5% in gradient going downwards. And the stopping side distance that one needs to stop before any collision in this road, they have given us as 128 meters. And they are asking what is the length we should have for this summit curve so that we can achieve this particular stopping side distance. Okay, so now we'll remove this. You guys, if you guys remember the summit curve length calculation, actually it has condition. So we assume that, okay, let's assume that length of the summit curve is greater than stopping side distance. Then it is given as ns square by 4.4. When we assume that length of the summit curve is less than stopping side distance, then we give it as n by, sorry, what was this? 2s n 4.4 by n, I think. Who can tell me whether I'm correct or not? I'm still waiting. No one is saying
Right,
whether
right.
I'm.
This is
Okay,
right.
good, good. Yeah. And this n is the net change in gradient in, sorry, in absolute terms, not in percentage. So for our case, our starting was 3% positive gradient and the the ending of the curve was 5% negative gradient. So 3 minus of minus 5 is 8%. So let's assume that L is actually greater than the stopping side distance and calculate our L. So we will have 0.08 into S square, 128 square divided by 4. So what's the answer in this case?
298, sir.
298. Correct. So that is the answer. And actually you can see this 298 is greater than this 128 that we assumed initially. So our answer is correct. Now, let's say this is a question, and instead of this information, I give you additional information. I say to you that your headlight, the eye height of the driver. So this is the vehicle. and this is the driver. This is sitting here. The eye height of the driver is some 1 meter, and the headlight height is some let's say 0.1 meter. Then what do you think will change in this formula? What do you think will change in this formula?
Length of curve will change.
Yeah, but what will change in this formula for the length of the curve? So, okay, so I will tell then what is going to change. See this 4.4 that we get. Have you ever wondered why we get this? Yeah, so Satish Babu has said that so 4.4 will change. That is correct. How we get this 4.4? We are memorizing the formula, that is fine. But just if in the interview they ask, what is that 4.4 is coming from? The 4.4 is nothing but
Square root of 2h plus.
sorry, you can say
Actually,
completely.
yes. Actually, they assumed certain dimensions of the vehicle and they derived the headlight side distance is 0.15 about the road, and the eye of the driver is around 1.5 or something.
So yeah, partially correct. So I think it is Satish who was speaking. So Satish is correct about the way this is calculated. So it is calculated based on the eye height of the driver and the headlight height of the car. So under root 2 into the eye height of the driver plus under root 2 into the headlight height of the car, and then square. So conventionally, we assume that the eye height of the driver is 1.2 meter and the headlight height of the car is 0.15 meter. And when you do that, you get the denominator close to 4.4. But in this case, if you do, you will get root 2 plus, I think, 0.2 square. So this will be different than 4.4 and your answer will vary. Okay, just something to note. Okay, next question. Okay, I think I removed everything else. Okay, so the first question I forgot to. Yeah. So next question. A circular curve of radius 200 meter, a coefficient of lateral friction 0.15, and the design speed 40 kilometer per hour, and radius is the equilibrium super elevation for equal pressure on inner and outer wheel would be how much? So what is this question actually asking us? So if you remember, in the first question itself, we discussed that when we are on a horizontal curve and the car wants to go fast, we provide an embankment. We provide elevation difference between the inner edge and the outer edge of the curve. And this actually is called the super elevation that we have provided. And this question is asking us to calculate the equilibrium super elevation. So my question for you guys now, so you would have done actually the design of equilibrium super elevation. Do you guys remember the steps we took in that? Just a refresher. It has nothing to do with this question. Just a refresher. So in that case, we will be given our lateral friction coefficient and maximum speed and design speed or maximum speed, and then the radius, and then we will be asked the super elevation. Here we are asked equilibrium super elevation, and we have been given a condition that in both the cases answer is going to completely vary, and we'll see actually what happens and why it varies. So okay, so no one has spoken. So the steps that we actually use when only this to calculate the super elevation is given to us is we calculate this. So based on the equilibrium of forces that I'm not going to show here, we get this formula for our super elevation, that is E. E is equal to V square by RG. Okay, this is something we will get. Now, when we are doing the design of our super elevation for our embankment or the curve, horizontal curve, first step, you calculate your E for a 75% of the design speed. If this E is less than 0.07 for a horizontal curve, and I think for a plane, so actually basically meaning 7% gradient for a plane area, and 4% if it is less than 4% for your urban area, and less than 10% for your hilly area, then you are fine, good to go. But if it is more than these values, then you go for a second step. You say that I will add my lateral friction to this, and now I will see and assume this lateral friction also to be 0.15. That is the maximum value of the lateral friction that is allowed. So I'll assume this value for the friction, and I'll consider the whole speed, the full design speed, and then I will calculate my E. So this thing we are doing when E from our first step is coming greater than these values. So for our normal place, let's only consider 0.07. So after doing this also, if we are getting more than 0.07, then you need to make a statement that we need to redesign the maximum speed. If it is coming less than 0.07, some value 0.06 it is coming, then you get your answer for this particular question as 0.06. So this is the general step when you are just asked what is the equilibrium elevation, and some detail about the terrain is given. Now when they are asking equilibrium super elevation and equal pressure on the inside and the outside, whole thing changes. Question becomes much simpler. In this case, you just have to use this formula that we have written on the right side, and you have to give the answer. So when we say it is equilibrium super elevation, equal pressure on both the tires, then we have to ignore our lateral friction, and we have to simply use our full design speed and calculate our E. So for 40 km per hour, if we remember, for our 80 km per hour, we got 22.22. So for 40 km per hour, we are going to get 11.11 meter per second. So if we use this and we calculate, we get this. So what is the answer? .0629 or 6.3%. Okay, is that clear? Good. So let's go to the next question. While driving at a speed of 30 km per hour and available friction 0.4. So one thing again, a hint, when they have not given whatever this which kind of friction this is, and it is, you see that it is around 0.3 to 0.5 in between this range, you assume that it is longitudinal only. Okay, so while driving at a speed of 30 km per hour, available friction is 0.4 down the grade. The driver requires a braking distance twice that required for stopping the vehicle when he travels same grade upwards. So when he travels up the same grade, okay, yeah. So the gradient is this part. If you remember, I said the stopping side distance is actually V in the speed into your reaction time plus V square by 2G F plus minus N. So they are asking this n from us here. And what thing they have given here, what hint they have given here is they are saying the braking distance. So this part only we have to consider. That's why we don't have to worry about what is the reaction time and everything. So what they have written is, if you want to explain in simple terms, that the stopping distance, the braking distance this vehicle needs when it is going downhill is D. The same braking distance when this vehicle is coming uphill is D by 2. So one thing this question does is it clears our concept that going down needs more braking distance. Now let's see how we can solve this. So braking distance is given as v square by 2g f plus minus n. So let's write this d as f minus n, because now we are actually saying that it is going downhill. Then d by 2 is v square by 2g f plus n. When we compare the two, we get 1 by f minus n is equal to 2 times f plus n. And upon solving, so let's simplify this expression. N is equal to f by 3. So your gradient is actually third of your lateral friction coefficient. We have lateral friction coefficient given as 0.4 by 3. It is going to give you 0.1333 going on. And then when we convert it into percentage, you will get 13.3 as your answer. Okay. I hope this is clear. Okay. Now let's go to the next question. Okay, so this is actually for our transition curve. What is the minimum length of the transition curve for a design speed of 80 kilometers per hour in a horizontal curve of radius 240 meters? So my question to you guys is, why do we provide the transition curve? So again, I'll repeat my question. You should know these things because these things will make good MCQs in the any exam. Why do we want to provide the transition curve?
To introduce a smooth gradient on the curve.
To introduce smooth gradient on the curve. That is one of the reasons. So when we have our straight road, then we cannot simply put curve directly. What we do is we bend our straight road little bit, so that there is a smooth smooth transition between the straight line and our curve. That's why we do. And why do we do that? To introduce centric. That is the correct actually. That is word to word. Muir has written what is the answer to this question word to word. So when we go from on a curve, you would also have felt that you get pulled to the outside direction of the curve. That is nothing but the centrifugal force. And it is 0 here, and it becomes, and if you suddenly go to this particular curve, it will become v square by r. This will be your this will be the pull force on you. This, and we want to avoid this sudden jump in the centrifugal force. So we introduce a transition curve so that the centrifugal force is applied gradually to our body. That is the role of the transition curve. Okay, and one more person answered. That also is an acceptable answer, but this is the exact word to word answer that people are looking for. Okay, so we are asked to calculate this. So this is, and another question. I think this has been asked in previous year questions. What is the general or what is the nature of the curve which we use to model this transition curve? Is it circle? Is it cubical? Or is it spiral? Or is it parabola? A, B, C, D. What is the answer? Spiral. Correct. Pallavi has given the answer. Spiral. And if instead of spiral you get something like clothoid, that also means the same. Means that also is the correct answer. I don't know what that means, but that also is the correct answer. Okay. Okay. Let's go to the question. How do we design the transition curve? So we get the transition curve as the maximum of three things. First is governed by the rate of change of your centrifugal force. In that case, it is written as VQ by CR. R is the radius, V is the velocity, and C is some coefficient which is given as 80 by 75 plus V. Okay, second, in this case here I think V is in kilometer per hour. Second option, second method, this is for the introduction of the super elevation. So as we have discussed, the curves are actually embanked on the outer edge. So the edge also is slowly raised when we are going in a curve. So the second condition is based on the rate of change of your super elevation. That is given as ENW plus WE. WE is the extra widening that you provide. There are some different questions which talk about extra widening. We are not discussing currently in this session those questions, but you just remember that WE is the extra widening that we provide for safety, psychological safety and mechanical safety. So that is another thing. But when it is not given, and for this question, this particular question, I have given you the details of the road, you just assume this as 0 and calculate your LS, calculate the the length of transition. Third is from the empirical formula, which is LS is equal to 2.7 V square by R. So the maximum of these three is the length of the transition curve. Let's calculate. So some of you calculate second, some of you calculate first. So for the second thing, I will give you a hint that I have given actually that super elevation we want to introduce is 1 by 15. So that is the value of E. It is a 2-lane road. So you have to to get the width W, you do 2 into 3.5. And the camber gradient is actually 1 by 50. So your N is actually 50. And also when I am writing this, there is an inherent assumption that I am taking, that is I am introducing this particular embankment on my road from the inner edge. If I am doing the same thing, embankment on the road from the center, something like this, then the formula just gets divided by 2 and we get this. But I am saying that I am doing it from the inner edge, so we don't have to worry about this. Okay, so that is for second part. Third part, V is in kilometers per hour, and let's all calculate and let's see what are the answers that we get. So I will calculate all the three one by one. If you want to go ahead and calculate any of the second part and you want to tell me the answer before I finish, that is also fine. First we need to calculate C, that is 0.516. So LS will be 22.22 cube divided by 0.516 into 240. We have 88.58. Second is E 1 by 15 into N, that is 50, into 2 lane road, that is 7. How much we have? T into 7 divided by 15. It is 23.33. Okay, maybe I didn't do this properly. Fine, we'll see what we get. Third part is from the empirical formula. 2.7 into V square, that is 80 square divided by 2 for T, we get 72. So the minimum of these three is actually, my bad. When I was designing this question, I didn't pay attention. So the answer has to be the minimum of these three, and because of my this addition, the answer will now become 23, which is not the case for this question. So let me just change this value to 1 by, how much? Let's say 1 by 150. That is your n, and then correspondingly this answer will become 3 times, which was 23.33 into 3. It is still 69. Yeah, we just change it to 1 by 200. We don't want to change the answer for the actual question. Yeah, so we'll do this. Yeah, 93.33. Yeah, so answer is going to be minimum of these three, which is minimum of 88.58, minimum of 3 and 72. Then final answer is 72 meters. Yeah, sorry about this. I didn't pay attention when I was designing this additional part. Basically, the length of the transition curve is the minimum from all these three formulas, and the answer for this question is 72. Okay. One thing to note here. See, none of you actually. I don't know whether maybe you remember this already. You have instinctively remembered this. But here, when we are doing this V cube, we are using it as meter per second. And here we are doing, when we are doing this 2.7 V square by R, we are using kilometer per hour. So you have to pay attention when you use these formulas. I also, after doing this question just now only, I realized that I should actually spend some time to mention this. Yeah, Muse wanted to ask something.
Sir, actually, you have mentioned there LS is minimum of these three values, but I think it should be maximum of three. I think this is a writing mistake.
Where?
Yeah, they're in
Okay.
the bottom.
No, actually it is minimum only. No, is it maximum?
It should be maximum of the three values that we can take it as a minimum of length for the transition curve,
Okay, okay. It
right?
should be maximum of the three values. Okay, initially I said maximum and then I calculated the minimum. Okay, yeah. So it should be maximum of the three values that should be considered for the length of the transition curve. But what they are asking here is the minimum length of the transition curve for the design of the speed, and the answer is given as 72. So out of these three, minimum, I think then there is a problem with this particular question.
Yes. The words are not framed the way it should be, I think.
Yeah, okay. Thanks, Miyu, for reminding. Yeah, I actually went ahead with the options and changed my definition itself to minimum. So everyone just correct, if you have heard this, that it is maximum of these three which has to be selected. So in this case it will be 93 point something. But I think there is a problem with this question, so that's why this 72 is only available in this option. Fine, just we understood some of the concepts, and thanks Miyur for this. This is maximum. Okay, now let's go to the other question. Rising gradient 1 by 1 in 50 meets with falling gradient 1 in 30. Which one of the following is the length of the vertical curve in the stopping side distance? Now, I have a question from you guys. Which type of curve this is? Is this a valley curve or is this a summit curve? Rising gradient?
Summit.
Correct. Very good. So we have a rising gradient 1 in 50, that is 2%, and falling gradient 1 in 30, that is 3.33%. This is a summit curve with a bump. So the net gradient change n is 2 plus 3.33, that is 5.33. And just revision of the formula. This is just another formula based question. LS, we have to calculate the length of the curve when we have been given the SSD, that is 120 meter. So again, let's assume that L is greater than S. Oh no, let's assume first L is less than S. So what is the formula? 2S minus 4.4 divided by N. So 2 into 120 minus 4.4 divided by N is 0.0533. So what is the formula? No, sorry, what is the answer here? 240 minus 4.4 divided by 0.0533. We get 157.44. Our initial assumption that L is less than S is wrong here. So we have to calculate again, assuming that L is greater than S. L is greater than S. In that case, the formula is N square divided by 4.4. So it is then 0.0533 into S square 120 square divided by 4.4. And when you do the calculation, you get the answer 174 point something or 173. So the closest option is 174 meters. It is just a repeat of our previous question. I don't think there should be any doubt in this. Okay, good. We'll go to our last question for the day, or second last question for the day. So while aligning a hill road with a ruling gradient of 6%, a horizontal curve 75 meter radius is encountered or is introduced, whatever. The compensated gradient at the curve will be. This is now the question for grade compensation. Okay, and they are asking compensated gradient. They are not asking what is the grade compensation that you will provide. So what is the formula for grade compensation? It is 75 by R or 30 plus R by R. R is the radius in meters. Now what is it? Is it maximum or is it minimum? What do you guys think?
Minimum.
Correct. Very good. It is minimum. And even after this, we actually have to check something. Right? So let's calculate and we'll do the checking we have to do after this. Okay, so 75 by R is 1 and 30 plus R by R, it is definitely going to be greater than 1. So let's just write 1 point something here. So from this calculation, the grade compensation comes out to be 1%. So the compensated gradient is going to be 6 minus 1, that is 5%. Now I have a question. Let's say the aligning hill road, the ruling gradient for this particular hill road was not 6% initially, but it was 4.5%. Then in that case, what is the compensated gradient?
Based on calculation, it will be 3.5.
Based on calculation, it will be 3.5. That is correct. But there is a very big but here. That is your compensated gradient should never fall below 4%. So you will only compensate your gradient till 4%. Even if you are getting 1% from here, your grade compensation in that case is going to reduce to 0.5%. So this is how they get you. This was a pretty simple question, just application of formula. But in GATE, this is most common for error, that you calculate your grade compensation, but you overlook that your initial grade ruling gradient is very close to 4, and you apply, and you don't even check whether after applying the compensation your gradient falls below 4%. So this thing you should keep in mind. Okay, now let's go to next question. I will remove this to avoid any confusion. So this is the last question for today. What will be the non-passing sight distance on a highway for a design speed of 100 km/h, nothing but 27.77 meter per second, ascending gradient on an ascending gradient road, that is your small n is 2% positive, assuming that the coefficient of friction, that is F, is 0.7, and a little bit surprise, that is the efficiency of your braking mechanism is 50%. So something here. So this question actually was incomplete. I don't know, maybe they are asking us to remember that at 100 km/h, your reaction time is 2.5 seconds. So because in the gate, this thing will never happen. So I'm just giving you this value here, that your reaction time is 2.5 seconds. Now the stopping sight distance we have to calculate. Non-passing sight distance, just nothing but fancy way of calling stopping sight distance. Let's calculate that. So that is nothing but V into your reaction time plus V square by 2G into a slightly changed formula. Previously, when we wrote F plus minus N, what we assume that our braking mechanism is 100% efficient. But if it is not 100% efficient, we have to multiply this with the braking efficiency. So F into mu plus minus N. And since we are on an ascending gradient, our braking side distance, or our stopping side distance, is going to be reduced. So the denominator is going to be plus N. So let's do the calculation. Zero 0.7 into 0.5, nothing but 0.35 plus 0.02. So what is the answer? Oh, I have to also calculate. Yeah. Now let's calculate 27.7 square. 105 plus 27.7 into 2.5, 174.9. So 175 you can say. Again, the answer is, the closest answer to this is 176. So we are going to select 176 as our answer. And again, if we were to encounter another question in which we were asked to use this stopping sight distance, what we will use? We will use 176, not 170. Okay, so these are all the questions that I plan to discuss with you guys today. If you have any doubt, you can ask, or if not, then we'll meet again next weekend. Sorry. Yeah. Okay.
Sir, I do have a question. This is actually regarding the super elevation. When we are calculating the minimum radius beyond which there is no requirement of super elevation. but still we
Okay.
are providing the super elevation in the form of camber. And for that calculation, whether we need to take 100% of the design speed or 75% of the design speed.
So when so
When we
the
are
questions.
calculating, the question is like if we are calculating the minimum radius beyond which there is no requirement of E super elevation. For that case, whether we need to take 100% of the design speed or 75% of it.
You have to take 100%. Only for the super elevation calculation, we use 75% as in the step 1 also only.
Okay.
But when you are talking about calculating the our ruling minimum, no, I remember, then we use full speed.
Okay.
I think this E plus F is equal to V square by RG. We use this formula.
Okay.
Okay.
Okay, thank you.
Okay. So guys, thank you for joining the session, and we'll meet again on the next session next week. Bye.